record this. So for this picture, you first of all want to draw attention to your parallel lines. You may want to turn your paper so that you can see them horizontally. So we actually have two transversals that are acting on this problem. So we should notice this is one of the transversals. And so we can use the 81, which is along the parallel line in this transversal. We can follow along the transversal, and you have two options. You could either use corresponding and put 81 here, or you could use alternate interior angles and put the 81 here. So that's how Joseph got the 99 for y, because these two angles together have to form a linear pair, which are supplementary, by using your angle addition postulate. So to get the 99, we did 180 minus 81, and that got us our y is 99. Now, the problem with the 37 is that 37, if we trace the corners of the angle, it actually doesn't fall on a parallel line. The vertex does, but like one side of it doesn't touch the vertical line. It actually touches both of the transversals. So we really can't use parallel lines and corresponding angles, anything like that, to figure out the angle measurement. But what type of angles are these? They are vertical. What do we know about vertical angles? They're the same measurement. They're congruent. So if this is 37, that's also 37. And then the last thing that we can do then to find x is we should notice that there's a triangle in this picture. At least this is the easiest way, I think, to do it. You also could add 81 and 37 together to find out what that whole angle is. But I would use the triangle. How many degrees did we figure out are in a triangle? 180. So remember, triangle sum theorem. Tells us that there's 180 degrees in a triangle. So we would just need to subtract 81 and subtract 37. So what should we get for the measure of angle x? Ethan?
62.
Good, 62. Now, you also could have used the fact that these three angles up here are forming a straight line as well. So if you wanted to, you could have done 180 minus 81 minus 37, and you would have gotten 62 here. And then you could use alternate interior angles to find out that x is 62 if you don't like triangle sum. All right, the homework, let's take a few minutes to check over this. And we're going to look at our section 3.2 day 1 notes. Just a heads up, we do have a quiz coming up, but not until next Thursday, so a week from tomorrow. So we are going to learn 3.2, we're going to practice, and then we'll finish up 3.2 next week. Remember, you don't have school on Monday. So we'll have Tuesday, then Wednesday will be review, quiz will be Thursday. The way our best is just to use the diagram to the right to answer the following questions. Angle 1 and angle 8 are what type of angles? Angle 1 and 8. You can draw attention to your two lines. We do have only one transversal. What type of angles are 1 and 8? No? Alternating exterior angles. Very good. How about 4 and 5? 4 and 5. No?
Alternating interior angles.
Good. Alternating interior angles. 6 and 4. 6 and 4. Joseph?
Same side interior.
Good. Same side interior angles. 7 and 6. 7 and 6. Blue? Those are vertical angles. So vertical angles, remember, have nothing to do with parallel lines. Vertical angles are just formed by two intersecting lines, and they're the opposite ones. And 3 and 7. What type are 3 and 7? Joseph? Corresponding. They're in the same relative location. Again, one way to identify, one is inside, one is outside. That's usually when you'll get your corresponding. Okay, corresponding angles, some of you are writing CA, just fine, as long as you know what C stands for. Some people, when I call them, are saying complementary or congruent instead of corresponding. So just make sure you're thinking that through. So today what we're actually doing is we are going to prove the lines are parallel. So in all of the other problems I told you, like, line L is parallel to M. Today, I'm not going to tell you they're parallel. We're going to actually prove that they're parallel using some converse theorems. So in the last section, we learned postulates and theorems that told us if lines parallel, then corresponding angles are congruent. That was our corresponding angles postulate. Also told us that if lines were parallel, then AIA and AEA, alternate interior angles and exterior angles, are congruent. You can use your congruent symbol if you'd like. And we also learned that same side interior and exterior were supplementary. So if you remember earlier in chapter 2, we did all those sentences where we were like, if it is period 2, then I'm in honors geometry. And then we would switch it and find the converse. If I'm in honors geometry, then I'm in period 2. That's what you're going to do with these. These are conditional statements. These are if-thens. So what we're going to look at today is the converse, which is to switch the hypothesis and the conclusion. We're going to apply this to theorems and postulates, not just to sentences. So today we will just switch these around, and if we can prove the corresponding angles are congruent, then we can conclude, the conclusion will be the lines are parallel. So just flipping those around. And we'll eventually do some proofs like we did yesterday with this. The proof statement will be to prove line A is parallel to line B or something. So when you're writing these out for the reasons today, you're either going to write it out like this, or you're going to have to say the converse of the corresponding angles postulate. So if you're somebody who's been writing corresponding angles postulate, you will have to write the converse of alternating interior angles theorem. But most of you have been writing it like this, which is how I do on the board. All right, so we have a couple, the postulates, they actually write them out for us, the converse, converse, and converse. So these just tell us if two lines are crossed by a transversal, and we see a pair of corresponding angles are congruent, then we can conclude the lines are parallel. So if angle 1 is congruent to angle 2, those are corresponding, then we can conclude that line L is parallel to line M. Again, in our past problems, I've told you they're parallel, and then you conclude one is congruent to 2. We're just going in the opposite order. The next one is the converse of the alternating interior and exterior angles theorem. So alternating interior would be 1 and 2. So if we know that angle 1 is congruent to angle 2, by the converse of the alternating interior angles theorem, we can conclude that line L is parallel to M. Using the same picture, we have the converse of the same side interior angles theorem. So if we can prove that 2 and 4, which are same side interior, are supplementary, then that would prove that line L is parallel to M. You just need one pair of angles that are a special type that we know to prove congruence or supplementary, and we can conclude that the lines are parallel. Now there's 2 additional theorems that we learn today. You won't be using these in proofs. You'll be using them in problem solving, finding angles and such. So theorem 3.5, again, the number is completely irrelevant. We're just understanding the content of it. It says if 2 lines are parallel to the same line, so if you have 3 parallel lines or 4 parallel lines, then they are all parallel. So if A is parallel to C and B is parallel to C, then A also has to be parallel to B. Basically all 3 of them are parallel. Okay. The next one says, if in a plane, if 2 lines are perpendicular to the same line, so if M is perpendicular to T and N is perpendicular to T, what could we conclude about M and N? They're parallel. And that's really actually using the converse of the corresponding angle theorem, Because if you know that these are perpendicular, you would be able to conclude that each of these is 90. And then these would be corresponding angles, right? So corresponding angles are congruent, then the lines have to be parallel. We would say line M is parallel to line N. So just like we've been doing in the past, we're going to trace the angles. We're going to identify the transversal, which remember is the line they both touch. And then we're going to try to identify the possible pairs of parallel lines. Okay? So we are going to start off by tracing the angles and then working from there. So which line or segments are parallel? Justify your answer with a theorem or postulate. So we're either going to write out if some type of angle are congruent, then lines parallel, or using our converse word. So in picture 1A, they've given me that these two angles are congruent. So let's take our pencil and let's trace the corners of the angle. You'll see that's step 1, trace the corners of the angles. Step 2 says to identify the transversal. Remember, the transversal is the line they both touch. What is the transversal? We'll have to use letters, like line AB, line CB, since it doesn't have a little letter. What line is the transversal? Joseph? EG. This is the line they both touch, so you can just write transversal, or T, at the end of it. So if that's the transversal, what are the potential parallel lines? Well, the other two lines that they touch should be this and this. Now, before I say that they're parallel, is this a type of angle pair that I know based on parallel lines? Are those alternating interior, same side interior, corresponding? What are they? Yeah? These are corresponding angles. This is in the top right corner, top right corner. So since corresponding angles are congruent, we can conclude that the lines are parallel. So we will say that line BE or line EB, it doesn't matter what order you use, is parallel to line CG. And our reason for that is the converse of the corresponding angles postulate. But I'm just going to write out if or since corresponding angles are congruent, then the lines are parallel. Again, if you prefer, you can write the converse of the corresponding angles postulate. But I always write it in the if-then form. Okay. Now the next one has segments instead of lines. Again, go ahead and trace the corner of the given angle. So we have 45 degrees and 45 degrees. Identify the transversal. What is the transversal? It's actually a segment this time. Segment what is the transversal? The line they both touch, or segment they both touch. Okay?
Segment MR.
Segment MR. Right here is the transversal. Okay, so the possible parallel segments then are CA and HR. Again, check and see, is this a pair of angles that we know? And if you need to, you might need to extend these to be able to see it. Are those a type of angle we know? Okay. These are corresponding again. Top left corner, top left corner. So these are corresponding angles. So yes, these will be segments that are parallel. So we'll say segment CA is parallel to segment HR, or AC and RH. Order doesn't matter. But I use segments because in the picture it does appear to be segments. Same reason as before. Since the corresponding angles are congruent, then our lines are parallel. Okay, now the next one doesn't mark anything in the picture, but they do give us a given statement down here. They tell us that the measure of angle J plus L equals 180. We know if two angles add to 180, that means they're supplementary. So let's go ahead and trace angle J, the corner, and angle L. If those two angles are supplementary, which segments are parallel? Remember, identify your transversal first, and then identify the other possible segments that could be parallel. Which segments would be parallel? Yep.
Segment J and segment L.
Segment what?
JO and same LM.
Yes, JO and LM. This segment JL is the transversal. That's the line they both touch. So the potentials are these two. And these angles right here are same side. Oops. Interior angles. So kind of ignore the KM when you're looking at these. Those would be same side interior, which they told us they're supplementary, therefore they are parallel. So our reason would be if same side interior angles are supplementary, then the lines are parallel. Or same converse of the same side interior angles theorem. Okay, I'll do one more with you in the next set, and then I'm going to have you guys try them on your own. Now, this one, I apologize, it has a bunch of questions with one picture, so you don't want to use your highlighters, just use your pencil, not a pen, because you'll kind of want to erase each time. They ask us, and this is, your quiz will have questions like this. I'm telling you. So make sure you study these. There'll be some in the homework as well. Using the given information, which lines, if any, can you conclude are parallel? Justify each conclusion with the theorem or postulate. There's a possibility that you could say they're not parallel or not possible to conclude. So, same thing that we did on the last one, we're going to trace angle 4 and 5. Identify the transversal. Which line is the transversal? Julian, which line do you think is the transversal? The line they both touch.
G.
Line G. Good. This is acting as my transversal. So the possible parallel lines are the other two lines that they touch, which would be J and K. Now before you tell me J is parallel to K, make sure it's a type of angle that we know. What, what type of angles are 4 and 5? Joseph? Alternating interior angles. And we know since those are congruent, that would prove the lines are parallel. So we'll say that line J is parallel to line K because since or if alternating interior angles are congruent, then our lines are parallel. A lot of you on your quiz will write this backwards by accident. You'll say if lines parallel then. If you look at the sentence above, you started out with congruent angles, you're ending with parallel lines. Your statement has to start with congruent angles and conclusion has to be parallel lines. So just make sure it matches up. See if you guys can try the next 4. Again, we want to erase and kind of reset the picture every time. Struggling over them. Some of you got it pretty easily, but tracing our angles 3 and 11. What was the transversal for 3 and 11? What line did they both touch? No? J. So this is my transversal, which means my other possible parallel lines are G and H. Are these a type of angle we know? Yes, they're corresponding. So we should say that G is parallel to H because if corresponding angles are congruent, then lines are parallel. And make sure that the order matches what the statement is. Congruent angles, then parallel lines. Corresponding angles are congruent, lines are parallel. All right, 7 and 10. So let me erase. 7 is down here. 10 is all the way up here. So if you try to look for a line that they both touch, it doesn't exist. This angle touches K and G. This one touches H and J. So there's no transversal. So this is not possible. You don't have to say why, but I'm just going to put that there's no transversal. Now some students are like, but they're alternating exterior, but they have to be along one transversal. That's the definition of alternating exterior. So that's not possible. I saw a lot of you getting that one, which was excellent. All right, 8 and 15 are supplementary. So 8 and 15. What's the transversal there? Which line do they both touch? No? Line K. So here's my transversal. So the possible parallel lines are then G and H. Are 8 and 15 a type I know? Type of angle? Look at them. You might want to turn your paper. They're inside of the red lines. And, Emma?
Same side interior.
Good. Same side interior. Some students will think they're same side exterior because they see them outside of these lines. Make sure you're looking at the red lines. So this one should be G is parallel to H. If SSI are supplementary, then the lines are parallel. Okay. Then the last one, I saw a bunch of you putting yes, and your reason is not a reason that would work for parallel lines. So 9 and 12 are congruent. If you try to find a transversal, the line they both touch H, and they both touch J. So technically there's two transversals. They also never touch K, which would be the parallel line, or G, which would be the parallel line. So this one is not possible. Technically there are two transversals, and they don't touch a pair of parallel lines. Okay, vertical angles are always congruent. You don't need parallel lines to have that. Okay, I'm telling you right now on your quiz there will be a section like this. You'll practice it in your homework, you'll also practice it on the study guide. But just make sure that you again remember to write the reason in the correct order, or I saw some of you writing the converse, just make sure you write the converse of whatever theorem or postulate. All right, the rest of the problems are actually really similar to the ones that we've already done where we found X or solved for X. The only difference is that they're not going to tell you the lines are parallel. They're going to say, find the value of y that proves the lines are parallel. You're doing the same thing you've done before. You're identifying the angle pair. You're either setting them equal to each other if they were congruent, or you're adding the expressions and setting equal to 180. Now the only difference is that you may need to use one of the types of angles we know to fill in the diagram. You can copy and paste any numbers you need to wherever they might need to go. So kind of like the bell ringer today. So looking at this, if we want to prove that line A is parallel to B, we want to look and see what type of angles are these. Joseph?
Corresponding.
These are corresponding angles. So we need to prove that these corresponding angles are congruent in order to prove that the lines are parallel. So if they're congruent, that means they're equal. So 65 equals y plus 35. And we would subtract 35 on both sides. And we'll get that y has to equal 30. So this should say when y equals 30, then line A will be parallel to line B. So change that x to a y. So kind of the same thing we've been doing. It's just changing the order of the statement at the end. Now the next one, as you can see, looks more confusing. Okay. Now remember, the goal is to prove A is parallel to B. So you might want to highlight those lines. If you want to prove A and B are parallel, that middle line is actually there to distract you. You're not going to use it. So if you want, you can take and just kind of scribble it out just to kind of help yourself to kind of ignore it. Now, whenever I trace the two angles that I'm given a 70-degree angle up here, and I'm given 5x minus 15. So 70 is outside, 5x minus 15 is inside. So one's exterior, one's interior. Maybe they're corresponding. Well, no, this is in the top right corner. This is in the top left corner. So this is not a type we know. So we actually need to take one of the measurements and move it to its congruent location to help us solve this. So for example, 70. Let's move this, copy and paste it. We know corresponding angles are congruent. So top right is 70, come down here and copy 70 down into its corresponding spot. You also could do alternate exteriors if you wanted to and put 70 there. Doesn't matter, but you're going to put 70 in one of its other locations. Now, what's the relationship between these two angles? Now that I moved the 70 down here. What's the relationship between these? They're supplementary, right? They form a straight line. So we'll use the angle addition postulate and the fact that they form a straight angle to add the two and set equal to 180. And you solve for x. So I get x equals 25. So again, sometimes you're going to have to move one of the angles you know to its congruent location, and then that will help you to find your final answer. That's why I say copy and paste. So it's like you're taking your mouse and highlighting that, pasting it down to where it's congruent. Again, you also could have put 70 down here, and you would have seen that these were supplementary, or you could have actually moved the 5x minus 15 up here corresponding. There's lots of ways to do it. Okay. The next one looks kind of like our bell ringer question. Find the value of x that proves A is parallel to B. So again, let's trace A and B, because those are the angles we want to prove are congruent. So one of these expressions is there to distract you again. Which one do you think is just there to distract you? You're not going to use it in the equation. The 5x, the 4x, or the 8x? No?
The 8x.
The 8x. Okay? It does not touch a pair of the parallel lines, so you're not going to use it to help you find one of the measurements. Okay? This is like extraneous information there to distract you. Now, when I trace the corners here, 5x and 4x, the same thing happens as last time. These are alternating, right? Alternating. But one's exterior and one's interior. So this is, again, not a type we know. So we have to copy and paste one of the expressions to its congruent location. It doesn't matter which one. Some students like to use vertical angles. I know a lot of you will like vertical angles. So if you want, you could take 5x and move it to its vertical location, which is right here. So if this is 5x, this angle also has to be 5x. If you don't like vertical angles, you could do corresponding. You could move 5x over here. Or you could do alternating interiors and move 4x over there. Lots of different opportunities. I'm just showing one. Now when I move 5x here, what are these types of angles now? The 5x and the 4x. Joseph? These are same side interior, which will need to be supplementary. So I'll get 5x plus 4x equals 180. So 9x equals 180 and x equals 20. So when x equals 20, then A will be parallel to B. If x equals anything that's other than 20, they are not parallel. Okay, last one. Again, we're trying to prove A is parallel to B. One of the expressions, again, is there to trick us. Which one do you think is there to trick us? It actually can be used, though. Noah?
5x.
The 5x. You don't need the 5x. Now, if you wanted to, you could copy it down here and get vertical angles. Some of you might have noticed that. And you can use it to find the answer, but you don't need it. So when I trace the angles this time, 4x, 6x plus 20, same thing. Alternating across my transversal, but one's inside, one's outside. So this is not a type we know. Who has a suggestion of which one I can copy and paste somewhere else? Doesn't matter, there's lots of options. But I'm either going to move the 4x to one of its congruent spots, or I'm going to move the 6x plus 20 to one of its congruent spots. What do we think? Use alternate interior angles, vertical angles, corresponding angles, whatever you want. No.
Vertical angles for 6x plus 20.
Good. Most students like vertical angles. So if I take the 6x plus 20 and I copy it to its vertical angle spot, then I'm going to look at these angles, which now they are same side interior, which are supplementary. So 4x plus 6x plus 20 equals 1. Combine your like terms. Subtract and divide. Should I get 6? Now just to show you another way you could have done that, again, most students like the vertical angles, and I like them too. You also could have done maybe alternate interior angles and copied the 4x here, and then you would notice that these are forming a linear pair which are supplementary. Yeah?
It'd be 20.
What's 20?
Oh, wait. I did that.
Did you set them equal? Yeah, you set them equal to each other. Should be 16, because they're supplementary. These are not congruent angles. One is acute, one is obtuse. So we are going to set them equal to 180. So just be careful. And there's some on the homework like this. See if you can try the closure. Find the value of x that would prove that A is. So we should have noticed that these were actually a type we did know. These are alternating interior angles. We know that they have to be congruent, therefore we would set them equal. And we should get x equals 19. So when x is equal to 19, then A will be parallel to B. All right, the rest of the time is yours to work on that homework.